Welcome to the Dr. Dana Show. Today we have an amazing guest, but before I introduce him, I'd like to pose a couple questions to you in the public. We have a lot of information coming at us in barrages every day about anti-aging, and this is ageless and life and trying to turn back the clock and beauty and a million different things you see every day being bombarded by these different things. But is aging something that we can actually turn back the clock with? Can we slow down aging and make ourselves more beautiful and younger and healthy every day? If it's possible, can it be done with some medicines called peptides or bioregulators? Well, I actually have a guest on the show today, Dr. Bill Lawrence, who's done this research for over 30 years, and he's proved it on himself. He's actually 78 years old. His own proof of the pudding is in his body, his mind, and his physique. So he's an American biogerontologist, which means he works with elderly people and older systems, older body systems. He has a PhD in nutritional sciences. He has a MS in psychology, and he's also an attorney from UCLA. So that's an amazing feat right there, just getting through the law school. He's worked with Dr. Kavitsen, who was the innovator of bioregulators in Russia for over 15 years at an institute in Russia. He's done an amazing amount of work, and we're going to introduce him in a second so that you can see what peptides and bioregulators do. Thanks for coming on the show today. And just say hi to everybody and tell us what a peptide is. What are these crazy things we're hearing about every day?
Well, it's a pleasure to be with you at this point. Yeah, let's start with the idea of can you reverse aging? Can you slow aging down and so forth? The short answer is yes, to a large extent. And what I mean by that is, a human biological system is incredibly, complex. We have over 1 trillion, and nobody knows for certain, but we basically have over 1 trillion cells. And the cell is the entire basis of everything that makes us human, that allows us to have, a life and so forth. If you're talking about anti-aging, you're really talking about, can we change 1 trillion cells, or at least a majority of those cells, and make them healthier, make them, people say younger, but basically revert them to a younger status? And the answer is basically, yes, we can. And the Russians proved it years and years ago. I've proved it over the last 10 years. I have 2 clinical studies where we're approaching that from 2 different areas, telomeres and what we call DNA methylation. Both of those studies that are now almost 10 years old prove that we can do what's people call cellular reprogramming. In other words, we can change the status of a cell from basically an older cell, which is not fully functional, to a younger cell. So the answer is yes, with the peptides we can. It's interesting. There is also another intervention, Dana, that has at least a lot of animal study proof. And I don't pay a lot of attention to animal studies because not all of the animal studies transfer over into a human being. But there is good evidence that caloric restriction, in other words, intermittent fasting, various forms of fasting, will also slow down and improve cellular function. Those are the only 2 proven methods that I know of after 30 years of research that can first slow down the process of aging and secondly, reverse it. Peptides are nothing more than small proteins. Everybody is familiar with proteins. We get them from food and so forth. But peptides are just a fraction of a protein. Somewhat arbitrarily in the different parts of the world, they define a peptide as a string of what we call amino acids. Amino acids are what we get out of our food, of course. And they define a peptide as simply a small protein of less than 50 amino acids in a string. You can have a line of these amino acids. And if it's less than 50, it's considered a peptide. If it's more than 50, it's a protein. So in essence, peptides are proteins, but very, very small ones. And what Professor Kavitsen and his team found out back in the 1970s is if they can create extremely small chains, literally just 2 or 3, maybe 4 amino acids, that it passes through all of the systems, all the human membranes, the digestive system passes through. These peptides can actually get to various cells, and the fancy word is reprogram. Basically, they can restore the functionality of cells if they're very small chains of peptides.
What is a bioregulator? Is that the same thing as a peptide?
It's a collection of peptides. We call them peptide bioregulators. The bioregulator basically means that it's a very short amino acid chain. Typically, again, 3 or 4 of the amino acids will make up a bioregulator. And the other part of it, in terms of defining what a bioregulator is that this is not a synthetic peptides. Compounding pharmacies, pharmacists, and so forth can create actually synthetic versions with chemicals of various peptides. And some of them are very helpful, very powerful, and so forth. We call these the synthetic peptides. The bioregulators are different in that they are exclusively from an animal, from calves and pigs. They are extracted from those animals in the form of they raise these animals very carefully. Then when they're still very young, for calves, it's about 12 months or so, they'll take the calf and take the organs out of that animal. They will then process, or what we call fractionate, those organs into amino acids in very small chains of amino acids. And then they will put them into injectable forms, or they'll put them into capsules. And if a human being swallows those, they get the benefit of the amino acid chains from that animal. So they're natural, what we call extracts. And that's why they call them bioregulators, is that they will bioregulate the cells in a natural way.
That's really incredible. Why did you pick working with, because you picked working with Kavitsen?
I came across him because of Google Translator about 12, 13 years ago. As I was searching, the world for anything to do with longevity and so forth, I began to see these Russian studies that Kavitsen had published basically in the late 1990s, early 2000s, where he was able to show with scientific proof, clinical studies, that he could perform the cellular reprogramming. In other words, he could change the nature of a cell. And he had many of those published at that point. And so I was so impressed because, as I say, for the last 20 years before that, I had been searching, and you would come across things that made a lot of claims, as you know, about anti-aging and slowing the aging down. But when I dug into it, the proof was flimsy at best and non-existent underneath those many claims. But Kavitsen has Kavitsen has over 700 published studies and articles and so forth, extensive. And when I say Kavitsen, quickly, without going into a lot of the history, what happened was back in the 70s, the Soviet Union was aware that the US was working on lasers that would have a negative impact on an opposing army. The lasers were designed to be able to blind the opposing army to destroy their hearing. And so the Soviet Union military gathered together a whole bunch of bright scientists and doctors, including Kavitsen, and said, you've got to come up with something that will fix this, restore, protect, et cetera, et cetera. In addition, what we're finding is with the submarine corps that we're sending out on 3 and 4 month long sailings, or whatever they call those excursions, or when they would come back after being in a submarine that was built perhaps in the 60s, had rather crude protection because they had these nuclear devices in these submarines, but they weren't well protected at that point. And so the sailors were coming back with all sorts of medical issues, primarily thymus or immune system deterioration. So the Soviet Union said, you have a blank check, you can spend as much as you want to, but we've got to fix this problem. So Kavitsen did a lot of research, discovered the earlier research that had been done that suggested that if you could use natural extract from animals, that you could create these peptides. And the idea of using natural extracts from animals is not new. I mean, for the last 5,000 years, basically medicine was from plants and animals. And it wasn't until maybe 150 years or so ago when the American pharmaceutical industry started to come into being, where they moved away from plants and animals into the sort of the chemical world. So a lot of money, a lot of time, probably I would say it was about 15 years after they started the research that they came up with the first couple of bioregulators, which was one for the pineal gland and then one for the thymus. And they actually worked. So with the submarine people, they gave them these peptides when they would come back from these assignments. And within a very short time, their immune system was back to normal. Then they started using them for the cosmonaut program, or what we called astronaut program. And then they used them for Olympic teams and various other things throughout the years.
So in the beginning, it was epithalin. Is that what they were using for the soldiers who were on the submarines when they got radiation poisoning to fix their thymus, basically?
Yeah, actually, the very first one was for the thymus. Yes. Quickly after that, they developed the epitalon, or epitalon, as we call it sometimes, for the pineal gland. And so those are the two they started with, and they ended up with powerful, powerful results in terms of cellular reprogramming, organ regeneration, etc.
You know, that research is in different lectures around the world. Tell the public how you changed, how your body changed. Can you do like a triathlon or a marathon now? I mean, with no problem. Like you see some of the guys on growth hormone who are like 7 years old, they can do whatever they want.
I would say pretty much the answer is no. Okay. What I mean by that, Dana, is that what the bioregulators are doing is regenerating internally many of the biologics, the organs and so forth, and the systems and so forth. So, for instance, the pineal gland peptides that we use will regenerate the entire hormone system, okay, the endocrine system and so forth. So, what that means is that these different organs and systems are functioning at a much higher level. Sometimes I'll say it's sort of like taking your treasured 1957 Chevy that you've owned for 50 years, and you've got 175,000 miles on it, and you take it to a master mechanic and you say, I love this car. I want to drive it another 100,000 miles. Go through and fix everything. Okay. And so the mechanic does that. Now, does the car run better? No, it was running good before, but is it going to go another 100,000 miles now? Yes. And that's what the bioregulators do.
Unless you decide to race a Mustang, a really 1,000 horsepower Mustang, then it'll keep working. That's what you're saying, right? More or less.
Well, yeah, what I'm saying is that the bioregulators regenerate organs. Now, you also have to sort of take care of the body. I mean, you can't go on a junk food diet,
nutrition
and gain lots
key.
of. So, yeah, you've got to do all the other things because you can accelerate, like with the car. Okay, the mechanic fixes everything, but you mistreat the car. You're racing it all the time and so forth, not putting in the oil, it can deteriorate quickly. But what the bioregulators are going to do is remodel or do a makeover, you might say, on most of the organs and systems, but not all. We can't say that the bioregulators will fix everything. What it does is it focuses on primary organs and systems and gives you at least 20 or 30 more years of functionality with that organ, but you can still treat it.
Yeah, you need to take care of yourself. I get it. So can you turn back pathology as well? So you said, there's a hierarchy of how healthy or how sick each person is, obviously, right? What if they're low functioning and you're using these peptides? Can you turn them around?
Well, I wouldn't say that we can turn them around. We can certainly improve their situation, okay? Because while I don't use them for the purposes of medical interventions, because I'm not a doctor, I'm a researcher, a scientist, we do know from the peptides that we use that if a person has, let's say, kidney deterioration, stage 3 kidney disease, for instance, if they go on the kidney peptide for a year, 18 months or so, we see their labs get much better. There's one doctor in the clinical studies who was able to take his patient off of dialysis, took him about 2 years, and nobody comes off of dialysis, basically. So that's sort of how it works. So probably I should explain about telomeres and DNA methylation at this point.
Mm-hmm.
Telomeres are the little end caps on all of our chromosomes. Sometimes people will say, a metaphor, it's like the aglet on the end of tennis shoes, where you're trying to lace up your shoe, and as long as that little plastic cap on the end of it is intact, you can lace up your shoe. Okay, but over time, after you've worn the shoes for a long time and so forth, when that aglet or plastic cap begins to shred a little bit, it becomes more difficult to lace up the shoe. Well, that's the way our chromosomes and the telomeres are. The telomeres are that little plastic end cap, you could say, on the end of the chromosome. The reason that it's so critical is that those end caps, the telomeres, every time there's a cell replication, because our cells are constantly replicating during our life, every time there is a cell replication or a renewal, you lose a little bit of that end cap, much like the tennis shoe, where you don't realize it, but every time you lace up that shoe, a little bit of that plastic cap is just deteriorated. And so over a period of time, we know that people who have shorter telomeres will find themselves aging faster. They will find themselves more vulnerable to disease. And there's hundreds and hundreds of studies. I think the last time I looked at PubMed, there were over 2,000 telomere studies published. And the consensus is that people with longer telomeres live longer because their cell replication continues at a much higher standard. And secondly, they have less disease. And so the goal with one of the two clinical studies that I administer was to see, and one of the holy grails really in science and medicine for years, 30, 40 years, can you slow down the loss of those telomeres, that is the shrinking of them and so forth? Can you in fact reverse that? In other words, can you regrow that end cap on the end of your chromosomes? And Kavitsen proved that 35 years ago in a published study. That was one of the reasons I ended up going to Russia, knocking on their door. And I basically said, let me in. I've got to understand what you're doing here. Well, and the side story there, Dana, is that they had never had any interest outside of Russia from other scientists, and particularly from America. There's just not much interaction between the world of science in America and medicine and that in Russia and so forth. They kind of ignore each other. I think so. Kavitsen was very surprised, I think, to find me knocking on his door. And they were very gracious and they allowed me in, and I've been with them for the last 10 years. Anyway, in terms of the biological aging, we can, with these peptides, and we've proved it. Kavitsen proved it. I've proved it here in America with 124 people in the clinical study. About 80% of them are physicians. I proved it over a period of about 3 years. We can lengthen people's telomeres and we can reset them to a much younger. So at 70, I think I tested last at 77, my telomeres are over a period of time, a number of years, had lengthened and lengthened and lengthened. And to today, my telomeres are equivalent to a 23-year-old male. That allows for a huge amount of cell replication.
So my next question is one that maybe a scientist doesn't really want to hear or answer. Can you keep lengthening your telomeres indefinitely?
Yes, you can.
Wow.
Yes, but you can't. That does not translate, Dana, into eternal life, because telomeres, as important as they are just one aspect of the aging process.
Okay.
There are many, many, many aspects of it, and there are other aspects that we're just learning about today. So yes, you can change this particular aspect of it, and that's very important. We can move on to the genes and the epigenetics as well. If you change both of those, you have probably added, based on Kavitsen's work, you've added between 30 and 40 years of human life longevity. In other words, I should be able to, unless I'm, run over in an accident or something, I should be able to live to 110 to 120 and not be much change from what I am today. There'll be more wrinkles, the hair color will go. So, but biologically, I will still be about where I am today.
Is that your natural hair color?
Yes. It's getting its gray.
Yeah, but it's still dark.
Yeah.
It's amazing. Yeah. I didn't want to ask you that question at first, but I figured, why not? That's awesome. You've done amazing work.
The hair probably has nothing to do with the peptides. I don't have any science that says these peptides can grow your hair or even keep it dark. It's probably a lot of the other things I do.
Well, this is a very interesting conversation. I know there was a lecture at A4M a year or two ago. It was a guy from, I forget the magazine, it was a big magazine, and he'd been going to the blue zones all around the world looking at centenarians. And at that point in time, the research or the idea was that the mitochondria was the key aspect of anti-aging. They looked at their different mitochondria and they saw that they were eating more polyphenols. Each one of the centenarians in all those blue zones were doing similar things, and all their mitochondria were very well formed, and there was more of them than the normal person, and they worked better. Have you done any research on mitochondria? Can you speak to that a little bit?
Yes, I can. Mitochondria, basically, it's the power, it's the energy that exists in the cells and so forth. What can be done with the peptides, it doesn't act directly on the mitochondria, but when it's going in and regenerating the entire cell, it has a positive impact on mitochondria as well as many other aspects. And so when we talk about cellular reprogramming, it includes improving the functionality of the mitochondria. So you have the telomeres, you've got the gene expression that we can improve, and indirectly things like mitochondria.
Yeah, it's interesting because when I was in Belgium, I guess 10 or 15 years ago, I was at a lecture with Dr. Thierry Hertog. He'd bring doctors over for 4-day lectures. He's an amazing guy. And at that time, they were selling these bioregulators there, or they had booths and things like that. And I believe Kavitsen was there because when I was going down in the elevator, there was a guy and he had a Russian uniform on. And I was just joking around with him. I said, "Well, are you Russian? And what's the uniform?" And I was pretending, but I was like looking like I was a little nervous because, I'm in Belgium, I'm American, I don't know what's going on. He goes, "Yes, I'm a Russian colonel from the military." I'm like, "Well, what are you doing here?" And it was actually Kavitsen, and he started telling me about the bioregulators himself. So I actually had to claim the fame to meet him. And so anyway, seemed like an amazing guy.
He's the brightest human being I've ever encountered. I would put him up against any of the famous scientists, including, Einstein and so
Einstein,
forth, in
wow.
a different category. Yeah, he's his is in the biological area. But yeah, brightest human being I've ever had the pleasure to meet and then work with.
You were blessed. That's amazing. I know you're a scientist and a researcher and you're not clinical, but could you speak to how people could start to use certain peptides so that they could, turn back the aging clock? I know you don't want to say, well, your hair and this aspect or that, but just say in general, just turning back the aging clock. Is it like epithalin and thymolin or thymogen, things like that, or KPV? We use that a lot, BPC 157. Just in general, what would you start to use?
Okay, well, we first have to separate the apples from the oranges, okay? The synthetic peptides that you just mentioned on the whole are chemical compounds come out of compounding pharmacies mostly and so forth. They are excellent. They are a wonderful, safe intervention for treating various problems, kind of what I would call short-term kinds of things, short-term like situations that are less than a year and so forth, okay? BPC 157, I take it myself, wonderful, for cell regeneration, wounding, wound recovery, and many, many other things. Also things like TB 100, and I endorse them all. I don't use them in the clinical study because there's some political problems, as you know, with the FDA, and they're always kind of looking over the shoulder of the synthetic peptide market and so forth. There's pressure by the pharmaceutical industry. Okay. The bioregulators are a long-term kind of program because what they're doing is they're not dealing with an acute medical issue right now, like a wound, let's say, like BPC 157. They're dealing with regenerating at the tissue level, literally at the cellular level, tissue level, at the organ level, the entire organ. So there are 22 different of these peptides, the bioregulators, organ specific. So there are peptides for the heart, the brain, the vision, the pancreas, the liver, etc. And so we use not so much because the clinical studies are all about anti-aging, but we don't ignore. So if someone comes into the clinical study and, we test for their telomeres, test for their epigenetics, but they also have a history of heart problems, we will then load on to the protocols a lot of heart peptides. And what we see within about a year or two, a remarkable cellular rejuvenation that takes place such that the organ itself is enhanced. So it's two different purposes, quick, short-term addressing medical problems, long-term organ regeneration.
Why has the world, it seemed like these were started to be experimented on and produced in the 1970s. Why has the world just found out about it in like the last 5 years or 10 years? Or I should
Well,
say
the first thing,
America. Why has America just found out
yeah,
about these?
because America, Britain, and Israel primarily ignore science that comes out of the rest of the world. That's why, particularly America. America only looks inward. If it's not American science, British they'll accept, Israelis they'll accept, and so forth. But they don't look beyond that. For instance, China has incredible scientists. Iran has incredible scientists, bright, bright people. But do the American science world and medical world ever pay any attention to them? No, they don't. That's the problem. Now it's changing a little bit. Again, because of Google Translator, scientists in America are beginning to look outside of America because that's too small a box when we're looking at the entire planet. You got
Right.
to look at everything.
Yeah, no, I totally agree. We use half the papers that I come across that we're using in our functional medicine are not American research. They're from other parts of the world. Is this treatment accessible to all Americans at this point, do you know?
Yes and no. Indirectly, before the U.S. proxy war against Russia, it was easy to order peptides, Russian peptides, and get them into the country. As soon as that war started, it became almost impossible, except jumping through a lot of hoops. You couldn't import them anymore. The customs people would grab them. They came in. And the other problem is you couldn't make any payments to the Russians because of the sanctions against Russia. You couldn't get any money flow out over Russia anymore. Now beginning to that's beginning to change a little bit. There are a couple of companies online that are selling the authentic Russian peptides,
Yeah, I saw them.
and through a lot of hoops, they can get them in.
Yeah, I actually signed up for, I think, Kavitsen a couple of weeks ago. I saw that online, or maybe, I don't know who sent it to me. How well studied are the side effects or the long-term effects of peptides at this point in time, would you say?
There aren't any side effects at all, zero. Kavitsen estimates that they've treated several million people because they were using it in the military. They've been using, they are at their 55th year of being used at the institute in St. Petersburg. So, and that institute also has a medical clinic as part of the research, and they treat Russians every single day, so forth. There are no side effects, and the reason is quite simple. These are extracts from animal organs, period. Nothing else in them. I was speaking in Stockholm a few years ago, and someone in the audience, when I was explaining it, a doctor said, "Oh, well, what you're talking about is nano steaks." And it took me a moment to figure out what he was talking about. Yeah,
Yeah.
yeah, these are little teeny microscopic nano steaks from an animal, so there can't be any side effects.
That's
It's not like a chemical
yeah.
that can go awry. Yeah.
So you can use them in IV therapy or injection or oral, all three. And I mean, you don't have to worry about the IVs. You can put in an IV whatever you want. I mean, normal saline, you could just dump them in there and use the IV, and you have no problems at all, for the most part.
That is correct. They're not usually, that's not the most popular way. They're either injectable or they're in capsules. More recently, there are a couple of them now that are a sublingual.
Oh, interesting.
The
Okay.
IV would be an unusual way, not necessary. If you can just do it as an intermuscular, why would you do an IV?
The question I have is, when they were doing the research in Russia, have they followed those soldiers and those people out like 10, 20 years and seen the benefits or seen their telomeres increasing? Do they look at any of that? Or those millions of people that Kavitsen was treating?
Well, I don't think they tracked the millions of people, but the people that they had in the clinical studies, which typical clinical study for the peptides would be between 200, 300 people, although there was one large study out of Siberia that had 11,000 participants. What they have is the longest study that where they've tracked people is 12-year study. Okay. And in that 12-year study, people got all the benefits. And the interesting thing about the 12-year study, unlike American drugs, where once you're on the drug, you're pretty much on it forever. With the peptide bioregulators, when it's done its job of regeneration of the organs, it's done at that point. That 12-year study, they only used the peptides for the first 3 years. And then 9 years later, they tracked them and so forth and got outstanding results.
Would you say they're regenerative then?
That is what they are. I mean,
Okay. Okay. I
what they're
just wanted.
doing, yeah, cellular level, tissue level, organ regeneration, and then they're done. I mean, once the mechanic has fixed the car with every new part, you're done for at least 100,000 miles. Yeah.
That's amazing. I'm pretty excited to have, all these different questions, and I'm asking you. Some of them are for my for my own clinical practice. But oh, thank
Yep.
you so much today. This is a great. I call you a hardcore scientist instead of like the softcore guys. Um, that you really did, and working with the Russians, that's pretty amazing because we know their research is valuable, very valuable, and it's done well.
It's been my pleasure, Dana.